All right, let's get started. To all my Twitch viewers, thanks for joining us on this wonderful evening. I know the weather outside is pretty atrocious. The bulk of the major winter storm seems to have passed, and at least here in Ohio, we just had the major snowfall, but nothing too bad, nothing we can't handle. I feel bad for all those in the southern areas that have the power outages and dealing with all the ice and the aftermaths. And I hope everybody down there stays safe and gets through this this mess safely and as quickly as possible. Because being without power and these horrible cold temperatures has just got to be horrible. So, to my YouTube viewers, catching this video much later, glad to see you're here with us, that you weathered these storms pretty good. Hopefully your power came back pretty quickly. So, and I'm just glad to see you're safe. So, the last video, we did the changes to the lower box, to the enclosure for the board, and threw together the lid, the top for it. And I went ahead and printed it out. So let me at least show you what we've got to work with. All right, so bit of cat fur. This phone camera is actually pretty darn good at picking stuff up, so it fits really well together. See some areas of improvement, things we need to fix. That's not a problem. Mainly here, we need to nudge this opening a little bit over this way. Just the USB port plugs in, but we want to give it more clearance. And we need to nudge this a little bit more over this way because it doesn't really give enough clearance for those guys. We'll drop this opening down a little bit lower. That's just way too much. We don't need a garage door for those. Just enough to handle the connectors going in, just to give enough clearance. We'll also see about adding maybe another opening for the fan. I think there's plenty of room here. Just change some of the numbers and add another set of rings in there so we can open that up. We're going to make the LED openings slightly bigger. Well, this would work. We'll make it a little bit bigger. That way, when we design and print the PETG light pipes, they'll just be easier to press in and fit. I've got an idea for the buttons, an idea for captives to keep the button actuators in place. We'll kind of try to flesh that out here. But all in all, she came up pretty good. Everything looks a-okay, and they're just some minor problems. And then on the PCB, I'm going to take note of this. What we're going to do is part of one of the revisions we're going to make is the pluggables. We're going to pull them out so we have a little bit of overhang on the outside of the box. That way, it's just nicer to plug them in. So I just don't like. That's just way too flush, way too much in there, and they're just a little bit difficult to pull out to remove because of that. So we'll go ahead and on the PCB, one of the revisions we'll make is we'll pull the connectors out. Fortunately, that's not going to be a stencil change because those are through-hole parts. So that's not going to be a problem for that. So with that in mind, I go back to Fusion. So I've already got it open. So let's go ahead and kind of jam through some of the things that we already know. All right, so oh yeah, also the rolled edge here, the fillet just didn't work out very well. It's 2 millimeters, so we're just going to go ahead and delete that, and we're just going to grab the edges rather than the vertices. And we'll just throw the fillet on there. We'll kind of make it a little bit more extreme. We'll probably go about like a little 3 millimeter fillet right there. Yeah, I think it was a little cleaner, a little neater. I like that a little bit better. So let's start here. So we'll figure out what we need to do to get rid of this big ass garage door. We'll drop that down a little bit. And I kind of want to open these just a little bit wider to account for any variables and manufacturing. So let's see here. So sketch 5, we can always show that. All right. So 17 from the bottom. All right. So that's from the bottom. So all that was kind of just thrown together without actually having the boards in here, the board in here. So I'm just going to kind of take calipers and kind of just swag it a little bit. So we're going to just remove 7 millimeters from that. We're just going to go 10. Wait, was that the... oh, no. 10 millimeters. So Fusion looks a little different. They updated. The software updated. So hopefully it's not too hard for you to see. I might have to... adjust the palette a little bit in case anything's difficult to look at, but yeah. So yeah, I just had a software update today, so hopefully it's not too horrible to look at. Ugh. Yeah, I don't like these pluggables like this being that far in. Yeah, we're definitely gonna pull those back. So let's see here. So we want to kind of open these up just a hair. So let's just go 16 millimeters, which will pull this open a little further, but let's go to 243. And that should open that up. So we're going to 10 millimeters. We're going to remember that. All right. All right. Come here. There we go. Get these garage doors closed. Too big. Okay. So what we need to do is kind of push this a little closer. So let's see here. Yeah, a little change like that might be more than enough. That's fine. The opening for this guy. All right. So then these guys right here. So this guy right here. We could kind of... oh. Oh, I hate when I accidentally throw my dimensions. Eh. Oh no. Let's see. There we go. Let's hide the bodies. There we go. Let's hide the bodies. Boy, that's a thing you want to say. You want somebody to hear you say, let's hide the bodies. There we go. Let's show the bodies. Okay. So remember, this is backwards because the lid's upside down, so it's going to flip over. So let's see here. That is a little wide, but that's fine. So what we're going to do then is open it up another millimeter, which is going to shift this guy over. let's see here. Let's go down a millimeter and open them up. Maybe 17.5. There. So that should take care of these guys. So this should take care of all those guys. Get rid of those excessively large garage doors that we don't need. All right. So let's hide that guy. We don't need that sketch open. Don't need that one. There we go. What in the world just happened? Okay. No. Okay, it was on this sketch. All right, so we're gonna. Okay. So these are the LED buttons, or the LED openings here. Okay, so I have to kind of remember to shift these appropriately. So let's make that 6 millimeters. Since we went 3 more millimeters, let's 42. .4. That way they're shifted over. Oh, go. That was a millimeter, so let's go 9.3 back that way. And there we go. 6x3. That's 3 millimeters. 39.5. Okay, so those guys should still line up. Now, as far as the fan is concerned, hopefully it doesn't bite me too much. All right. Got, because I might argue about these radiuses or the diameters here, but okay, we've got some additional lines in there we can get rid of. Let's see if we can get rid of that line, that line, that line, and that line. All right. Don't need that. Put you out of my way. So the screws lined up perfectly. So the geometries we're going to try to rein in a little bit. I'm almost hesitant to do this because I know it's going to end up fighting me. But let's try. Yeah, it's going to end up fighting me. Yeah, I don't know if I want to fight this right now. I'll leave that alone because what I'll end up having to do is, well, I mean, I guess I could throw in, dimensions for all of them. Oh, that's gonna get annoying. No. So yeah, what I'll probably be having to do is redesign that down the road. I'm not going to worry about it. It works. It's got good airflow. I get at full fan speed. I can feel it pulling air in through the vents on the side and pushing it out. So that is more than good enough for me. So we're not going to argue with that. The button actuators. It's a small button, but it doesn't have to be big for those. So we're going to work on the idea for those. Finish that sketch. So we're going to leave that drill there. Now, fortunately, so the idea I have is, so we need a way to captive the actuator. so it doesn't just fall out and it stays in. So one of the things we need to do is we need to kind of give it a little bit of a channel to help hold it in place. And then I thought of, well, for a captive, we could just like use a pin, that runs through the button and runs through like a slot and like kind of like the channel here. And I was thinking, well, I don't want to have to pay for more pin or for more hardware, but what we can do is we can set up and use a piece of filament for the pin right now, like a 2mm, basically to replace like a 2mm dowel. And maybe down the road, we'll actually look at finding little 2mm dowel pins, like steel rods to use, steel dowels as the captive. But right now, we'll just use a piece of filament. And that'll save us a little bit of effort and money and time on this. So what we're going to do is we're going to leave this so I can get some of the dimensions off of it. Because what I'm afraid of is, well, I don't know. It might be okay. Because if I rebuild that sketch, it's going to mess with everything else. Because the way everything in here likes to go. So we're going to grab here, part design. Create there. Okay. So we're just gonna make it a little square. We're gonna make the base square because it's just easier to do. And let's go 5 by 5. Sketch. Okay, so the first extrusion is 23.5. All right, so then we're gonna throw this guy right here on the face. We're gonna throw a circle. This guy, what's the diameter? 2 point something, 2.75. You know, 5mm, but I like doing this, 2.5. And what's the extrusion off this guy? 6mm. And this guy, we did that at 1.3mm. There we go. So we've got a button here. So what we're going to do, since it's square, first thing I'm going to do is kind of come here, kind of clean it up. This way it'll fit in the channel a little bit better. So chamfer on those corners. A millimeter. That way it fits in the channel a little bit easier. We're not fighting the corners. And then we're going to kind of select one of the faces here. We're going to create so the reason it's so large of the 5mm is because we're going to create a slot. Center slot. And we'll fix all the dimensions here. Okay, so we got that. What's the radius here? Gonna be point here, so 1.1. So we need so it's gonna be basically a 2.1mm radius or diameter. So let's go to 1.2. So we can have a 2.4mm opening there. Let's kind of bring that a little bit from the top. And this guy doesn't need to be this far from this close to the bottom. Okay. So that basically runs a hole through that guy. Close this. We're not gonna save those changes. This button actuator B2. We're gonna go and save it. Actuator B2. Okay. So now what we need to do is come over here to the button box. Create sketch. All right, so we're going to throw in a box here, and here, and then we'll throw in an additional box in a minute. So we know we're 5 millimeters on that guy. So we need to, so 5 millimeters would be 2.5 from the center of that. So we're going to go to 2.6. We're going to just open it up just a little bit. All right, that's that one. We're going to do the same here. Again, I know there's probably easier ways of doing this, but okay, so we're going to get that. Now we're going to throw in the shell around it. Go to 1.5 millimeter. Maybe. We'll have to see how it looks. All right, something went wrong there. Oh no. Nope. I get the dimension off of the center, not that guy. Let's see where you're at. Yeah, it's gonna kind of interfere, but that's fine. I don't really care too much about that right now. We could probably try 1 millimeter. 1 millimeter might be more than enough. All right, so we're going to grab that. Now, don't need it all the way. Extrude. 20 millimeters might be more than enough. Might be too much. But we'll see. And we're going to do, it's going to be a little tight, but that's fine. Oh, yeah, create a driven. Okay. Let's go 8. And 2 millimeters. Because we can always use a little bit of super glue to help hold the filament in place. So basically the button will drop in there. We'll drop the piece of filament in there. Push it through the slot on the button and the button actuator, and then that'll basically serve as a captive. So it'll let it fall a little bit, but it's not going to hurt anything. So sketch, extrude negative. Did that go all the way through? Yes, it did. And it didn't go all the way through everything else. So that way it catches both of them at the same time. Yeah, it kind of blocks that. It's a shame, but it's fine. I'm not going to sit here and complain and argue about it. It's a solution to a problem. I'm not terribly worried about that. And then like the light pipes that we're going to design for these guys, we could do that real quick as well during the session. They'll be kind of press fit in here. And we can use a little bit of super glue on the inside to kind of glue them in. But if they're press fit hard enough, it won't matter. So that should take care of that guy. So what we're going to do, make this a little bit easier. Push the to seat the light pipes. Another chamfer. Yeah, just enough. Should be more than enough. Well, that should be that guy. Let me get Big Studio open in the background. We're gonna save that. Start a new design. Boop. Boop. Hey now. No. Finish sketch. There's no sketch. Delete. No, I don't know why you did that to me, but that's fine. Okay. All right. So we have this guy, which I think is pretty good. Go ahead and so we know we are 6 by 3. Okay, 6 by 3. We're gonna finish that, and by looking inside the box, so we know we're roughly 25 millimeters. The LED. So let's try to go 24 millimeters. Let's go to 22. All right. All right. Now, one of the things we'll try to do here is kind of the same thing. We're kind of chamfer it a little bit. That way it kind of helps give you that little bit of leeway to help force it in a little bit. Kind of press it in. It shouldn't look too terribly bad from the outside of the box, as you still have like a 3 millimeter base here. So it might not look too terribly bad. I mean, we'll change it if we have to. It's fine. So we're going to name this LED light pipe. Light pipe. And we're going to save this. Light pipe. All right. 3D print that. Save that. Grab this guy. Here. 3D print. Save. Same thing here. This. Save. Overwrite. Okay. Boom. So we got this guy. So let's this guy, this guy, and this guy. Like I said, the bottom works perfectly. It gives the support, so the extra thickness that we put in down here. For one thing, the lip that we put in there really gives the board support all the way around. I don't feel it. That center really helps give that board just some solid. And then the buttons, you don't feel any weakness directly under them because of this right here. So that's actually very helpful. So let's go to downloads. Let's go to the lid. Actuator. Clone the actuator again. You know. Clone or auto arrange things. Okay. I don't want you auto arranging things because that's not supposed to be taken off the what the world are you doing? Bamboo? Everything fit on here before. Wow. Just shove that to Neverland, why don't you? Jeez Louise. All right. Usually the auto range works pretty good, but it got dumb there for a second. All right. So we'll save that, and we're going to add another plate because I need to add another material. It's going to be PETG translucent. And we're going to throw in the light pipe over here. And light pipe, we're going to set it to change filament, PETG translucent. And we're going to clone it 2 more times. Range. Because there'll have to be 2 separate, obviously 2 print jobs. Because PLA likes having the door open of the printer. And PETG likes having the door closed. Now over here, let's make sure we have global support. Make sure we have the brim. Always messes with the others. Okay, so we got there for the brim. Okay. Now we don't need the bottom. So what I'm going to do is we can hide that. And slice this. Boop. See what she looks like. An hour 26 minutes. I'm going to go and shoot it over there now. Or maybe not now because it doesn't realize I have black filament in there. I'll have to check that after the video. Is not a big deal. So I'll minimize that. So I say for now we're done with this guy right here. That's all the enclosure design we need to do. Building up like a little hardware list of like the button head screws that I'm using. So the fan I'm securing inside with nylock nuts. They're just easier to use than like lock washers and regular nuts. And they're really reliable. So I'm just going to be using nylock nuts. Try to find some black oxide ones. So one of the things we need to do then is while your project files. So So we're going to need open with LibreOffice Calculator. Then what we're going to do is projects. Oh yeah, we need to get the resistor box. I need to get it all documented. Maybe we'll do that next time because I want to get this stuff captured before we get too far along here. All right. Just going to kind of open with, leave it off. Calculator. Okay. So we're going to generate a new. We're just going to kind of keep this. We're going to kind of fix it because everything's going to be the same. So it's going to be 126. 126, 126. All right, that's that. So an ECR, ECN can have multiple requests in one shot. So expand the ground copper pores under the ICs to better pull heat away from them. Yeah. Helps if I can spell the ground plane as well. So one of the things we can do here is kind of do that. Expand the ground copper pores under the switching regular ICs to better pull heat away. Ground plane as well. Possibly add a large pore on the okay. So with anything like this, it's all about just thermal mass, and that's what we're doing. Just trying to. I have now. I think it should work here. Alt Enter, yeah. 2. So that's the one ECR because we already have the one to add the capacitor to the temp sense input, the 104 cap to help filter out noise. And then we have the one already for changing the USB UART chip. So this one is, then we're also move the connectors outside edges of the PCB further. Around 1.5 to 2 millimeter should be enough. Wow. Okay. 3. That's points for ESP RX/TX and the wow. Oh my God. Oh, amazing I haven't graduated school. Pluggable. Oh, that's a word. Is it just 1G? Nope. Reason for change. one, one, the were temperature rise and not enough at the full loading. Okay. Remove and would look. Well, what's that change? Yeah, to be honest, it would actually make it look better. To give them a little bit more clearance off of the out of the enclosure. It would definitely make it look better. There's no doubt about that. And three, not enough test points. Oh. And testing for a dev kit. So yeah, so obviously more, and would also give us more test points for our initial testing to help validate things, or, you know, test points are always a plus for something to be a dev kit. So if you pick up something like, if you pick up this unit when it's done and it's on the market, or you build it yourself, the new test points, the additional test points will be a boon, especially when it comes to trying to figure out if, like, you've got a stepper signal wrong, or, you know, to measure your analog value coming off of the temperature sensor, things like that. So, and to try to avoid that situation where we had to try to solder those fly wires in for the RX TX lines on the ESP32 to do direct programming to bypass the UART chip. At least with the test points, we'd be able to clip onto them. It could make some kind of adapter. Actually, I have things I could use that could clip onto them that I could just plug into the FTDI cable. So, all right. Hopefully I didn't file save as. Hopefully I didn't save it over the other one. If I did, I'm just going to smack myself in the face and do it the right way. But it's fine. The 126. Give me another day out. That's fine. Next is all approved. Blah 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 blah. That's one of the great things about doing this stuff on your own, is you don't answer to anybody else. And the other great thing too is no customer to say, hey, no, I want it this way. You're not fighting a customer, unfortunately. Customer work is great, doing things for... Oh, I forgot to do that. Again, we got to suss out a process for digital signatures, but it looks like there are ways to do it, and we'll have to dig more into it, but it's no big deal. So, we've got that guy. Let's go here to here, ECR number. No, I learned my lesson. Just copy the text. Well. All right, there we go. So now we have our log, we have our ECNs, ECRs for what we need to do. So what we can do then, okay, 9, boop. Oh crap, we're going to be adding a capacitor, that is going to require a new stencil. It's all right. We have enough parts. That's fine. We order a new stencil. I just didn't want to have to, but it's fine. Oh, well. Everything's fine. All right. All right. So let's kind of copy this stuff. Hello. Why you want to be that way, huh? There we go. Kind of pull you got here. Right. Right. Okay, so that's off the temp sense. All right. Now, where is that? That's off of here. That's getting a little noisy, a little messy. Gotta pull these guys out a little bit. So we can fill in 2 net labels here. ESP-TX. ESP-RX. No, you were actually working. All right. All right. New. It's kind of cool. We come over here. Come back over here. I already got quite a few right. ESP RX and ESP. There we go. So that'll add the 2 test points. For the ESP, TX, and RX lines. So we'll get that taken care of. Now let's go over to the stepper driver, where I don't have any test points. So let's throw. So we can grab this stuff. Pull you out of the way. Forgetting. Still wanting to do things like with Ultium and Circuit Studio, the shortcuts there. Okay, so we'll just go ahead and throw that there. Tie that in from here. Boom, boom. So that's that test point. God dang it. I keep wanting to hit control when to zoom in and out, because that's what I have to do in those other applications. Okay. All right. Let's get some more test points in here. Now let's So net labels is kind of STP enable, STP reset. Yeah, so we're gonna need a new stencil. Correction. All right. We're gonna want to do. Let's see this DR. So it's nice to see that it's naming nets after the ports by default, or did I? I don't know if I set that up or not. Get this guy in here. Yeah, so at the end of the day, this will end up increasing the overall BOM cost. That's STP step. Okay. Let's see how badly this clutters up the PCB before we so okay, so that's already been versioned to version 2 when I did that, because then the work will come in Odo to actually basically create a version 2 for this, update the BOM for it, and basically clean everything up in there, because we're going to obviously have all the new test points and stuff, the new capacitor that we're going to have to place on here. So let us go and grab this fella. So to tools, update PCB from schematic, update PCB, close. All right, so it wants to throw the scatter shot the parts there. Perfect. Again, I'm still let's say 1.27. I know there was something I did that it did all that text at the same time, but I don't want to accidentally that's fine. Where did all these extra resistors come from? What in the heck did it just do? Did I accidentally just throw a bunch of resistors on there and not realize I had done that? C30, yeah, that was supposed to be. What's R50? Where in the world? Wait a minute. Did you seriously? What in the world? Why in the world did you? Oh, there's no reason. It saw fit. It saw some kind of change on those resistors from the optos. Oh, that's gonna be fun to fix. Ugh. Why, Cat? Why? What happened? What did I do to make you so mad? Good thing it's only a small handful of resistors. So, one thing at a time. Let's. All right. Text. So we're going to grab prints. So this guy goes on here. I still need to get used to that because I've been using. Okay, so tracks. So what we're gonna have to do is kind of out of the way. Just. All right, that's fine. Make sure I have text. All right, well, let's see here. X. All right, that should be fine. That's fine. Here I go again. Can't remember for the life of me what I'm doing at the time, but you know, hey. All right, so we got the C30 dropped in. It's as close as I dare to really push it. Just to help kind of isolate some noise off of that guy. All right, so again, we'll figure out these resistors, where they're gonna have to go. All right, so test points. Let's go back to them. ESP32. Okay, so that's that guy. So 8 and 9 are the new ones added for the the RX and the TX. Wait a minute. Something tells me I've got my numbers. 0.635.127. Uh-huh. Eh. Oh, that's why. That's why it looked kind of weird. All right. I was looking at the for the labeling on the connectors here rather than the actual components. My bad. My bad. All right. So DP8. All right. So top. Again, I don't care if we applied. All right, objects. Really wish I had real quick. So we want to go X about 90. About 93 looks like. F5. That's 93N. Oh. Actually, we can XY that based off of this, 25. 25, so the Y is 20. Okay. A little tight, a little close. I think we might be able to push a little further over. 4. Yeah, that should be fine. A little tight, but that's okay. That's fine. RX and TX. Even better. All right. So this guy, we can kind of... pull off that guy. And we do have a couple inner layers we can look at. The plane. All right. Actually, there's nothing there. So let's go ahead and grab this guy off his via. Boom. Back to the top. All right. So that throws in those guys. Alrighty then. And then there's a couple additional schematic sheets we'll add. And but I'll explain those later. I know there's a real quick way that I adjusted text, but I'm afraid it would mess up the other text for like the labeling and stuff. So one pain in the butt for another. So yeah, that way we get that done. All right, so these should all be, yeah, stepper. Oh, there's the temp sense. So that's kind of the cool thing is we got plenty of room over here for the temp sense. All right, let's kind of give it a nice little 150. What's cool is we've already got an inner layer for it. So that would work. It looks like we're on this layer. Yes, sure. Routed connection. All right. And I'll run through and throw teardrops, you know, have it do all the teardrops back. Let's see how we are here. Let's look another test points that are where, okay. Looks like a lot of those test points is kind of be below the courtyard. It's kind of, okay, well, it works, I guess. All right, so that's that guy. These guys might... we will find ways to tuck these guys in here. It's going to be mad. Okay, step enable. It's good as a lot of them already have vias. And we can run them on, you know, the bottom side or something. So that guy, I mean, it's fine. They don't have to be perfectly next to each other, and that's fine. Well, it would be more. Oh, you don't want to put it there in front of that. That's a good catch there. Because we're just monitoring signals. We do have room down there for a couple of them. So let's see if we can. The thing is, do I want to, if we have enough room, maybe we'll put them from the micro step, but maybe we will see. So what are we at here? 85, 87? No, that's fine. So again, that's a courtyard. We have enough plane clearance there. Right. 8. So yeah, there'll be overlap in the courtyards, but that's fine. We've already decided that's okay. No. Oh. Oh, come on. Why did you move in? There we go. Only got 4, so if we put one here. Okay. There we go. Stop. We do this. Okay. So we go to the inner layer here. Okay, move you up a little bit. Not gonna hurt anything. That's fine. Don't think we're gonna be hurting any. So let's move you up a little bit. Too far. So 53. Enough clearance. Move you up the same. We're already at 7. Let me just try to get this a little bit. 7. 84. Let's see how you look. Okay. Should have plenty of clearance there. 77. This guy's at 84. Yeah, we should have plenty of room to plug, a connector in. If we don't, it's going to be a lot of fun. And we can pull this guy over here. Alrighty then. Okay. So it looks like we have step enable. Looks like we already have a signal line in here that we can pull off of for that guy. All right. Step reset. There's a FIA all the way down here for him. But, which is fine. At the end of the day, it doesn't really matter. I try to avoid putting more vias than necessary. All right. Step direction. Okay. It's like we've got a way in here. All right, step. It's like there's one over there. Oh, looks like we can route that guy. Hello? Oh, why you dropped off? All right. Yeah, I didn't throw in a ground because there's so many, you know, we've got a ground connection right here to measure these guys off of. So that's why I didn't bother throwing another ground line in. We've got plenty of grounds um, to hook up to and grab to. We got ground over here, a ground up here, actually two grounds over here. So yeah, we've got more than enough grounds down here. So I'm not terribly worried about more ground connections. We've got more than enough. That should be enough clearance for us to pop that guy. Okay, so since we're encroaching over an hour, we're gonna go ahead and just call it here, and our next video will pick up, and we'll finish off expanding these ground pours right here, moving the connectors out by a couple millimeters, and obviously getting these resistors back where they're supposed to be, which is kind of ridiculous that it's like this, but hey, you know, I don't know why KiCad decided to throw a fit on those, but you know, it is what it is. We'll deal with it. So moving these connectors might kind of, yeah, we're definitely going to probably need a new stencil because moving these connectors is going to throw these resistors off. We might have to move them around, shuffle them around to deal with it, but that's fine. We'll do what we have to do in order to accomplish our goal, which is to make everything look nice and fit in properly. So thank you for hanging out with me tonight. I really appreciate it. Thanks for checking us out on YouTube. This has definitely been a lot of fun. The only problem I have with doing these videos is it kind of forces me to slow down and wait to work on this project. Otherwise, I'd probably be, to be honest, done with it by now. Mainly just because, you know, I'd be working on this enclosure, getting the 3D printed all done, updating the board, getting it all ready to rock and roll already. So that's just the way it goes. So thanks for hanging out, and we will catch you in the next stream, the next video, which should be Wednesday at 6. Have a good one.